Greeting Dr. Hedawati. We are from Group 9. We'll be presenting on our assignment 1 entitled Intrinsic and Dissociation Coefficient Parameters Determination from Smartphone. I'm the first presenter and my name is Himalata Vasudevan and my metric number is CE2062. So now I'll continue presenting on the introduction. So this is the definition for the X-ray. It is to define the location and orientation of the camera reference frame with respect to a known world reference frame. So as you can see, the world reference frame, it refers to the 3D image. So next is the instri. The instri is to the link the pixel coordinate of an image point with the corresponding coordinate in the camera reference frame. So now as you can see, this is the perspective transformation model. So in the first coordinate, we can see this is the camera image. So this camera image, the 2D image. In this coordinate, we can see the instri. The fx and the fy stands for the focal length. The ox and the oy stands for the principal point. So move on, and here in this extreme, this is the radiational and the tangential distortion coefficient. So at the last coordinate, we can see this is the world coordinate. This world coordinate is the 3D image. So now I will continue with the objective. So the first objective for our assignment is to determine the geometric parameter of the image formation process. And the second is to eliminate the effect of lens distortion. This is for the second objective we can achieve by using the MATLAB software. So the third is to establish the correspondence between the images and a pattern displayed on the screen. And the final objective of our assignment is to evaluate the metric performance of different mobile phone cameras. So these four objectives we can know we either achieved or not by calibrating all the image by using the MATLAB software. So that's all from me. Thank you, and I will hand over to the next presenter.
Hello, my name is Devan Ravichandran. My metric card number is CE200222. Today I'll be presenting about our calibration method using smartphone. So as for the first step, we have to open MATLAB and click on the app icon on the tab top left of MATLAB front page. So once we click app, we have to choose the app we want to use in this calibration method, which will be camera calibrator, and this app can be found under image processing and computer vision category. As for the third step is once the window for camera calibrator is open, we have to add the 10 pictures as a sample pictures that we took using our camera. So once we have uploaded the pictures into MATLAB's camera calibrator, we have to do a little bit of setting up before we actually calibrate. So the setting up will be we have to change the radical distortion to 3 coherence. After that, we have to run the calibration and export the MATLAB script to the front page of our MATLAB. Once the script have appeared in front page of MATLAB, where we will obtain our focal length, principal point, and etc. Once we run the script that we have imported from the camera calibrator to MATLAB coding, the results will appear once we run the script that have been imported. So there will be two results that will be popping out, which is mean reprojection error per image and electrical parameter visualization. And the parameter for our camera, which is the focal point, principal point, and etc., will appear under command window in MATLAB. So that's all from me. Thank you.
Now we will continue with the MATLAB simulation. So for the first step is by choosing the camera calibration app. So this is the camera calibrator tab. So the second step is we need to add the images from the file. We were assigned to take 10 images of the checkboard from different angle. So as you can see, this is the image and the pattern properties. So the size of the checkboard square is 25 millimeter. So I'll click OK. So while after the images has been analyzed, so as you can see, all the checkboard images will appear at here. So this is all the 10 images. So all these images is taken in different angle. So now we will change the option to 3 coefficient. Then we will calibrate it. So as we can see here, this is the reprojection error and the uh, pattern centric. So from here we can see each images have a different uh, uh, reprojection error and camera centric. So you can see for the image 3 it's like 3 like this, image 4. So all this has been once has been rechecked. Now we will generate to the MATLAB script. So now we will run this program. Before we run, we will save the program name. So I will save it as vision. So once it's been saved, we add to part. So the program will be simulating to get the output. So as we can see in here, this is the output for, as you can see, the in string, we can get the focal length, the principal point, and the radial distortion. So this is all the our calibration from all the images. So the first figure is the graph of the mean reprojection error, and the second figure is the extinct parameter visualization. So that's all from me. Thank you.
Hello, my name is Devan Ravichandran from Vision System class. My metric card number is CE200222. Today I'm going to perform camera calibrator using MATLAB, and the phone that I used to capture all these images is by using iPhone 12 mini. Sorry for the inconvenience. I have to like preset everything in my MATLAB because it's quite slow when I do it in real time simulation. So this is how we add the images into camera calibrator. Once we do this, we just have to highlight all these pictures and click open. Once we open the pictures that we have been captured, so these are the images. the images that we capture will be displayed on the left side. So from here we just have to go option and change the radiant distortion to 3 coherence. Once we do that, we have to calibrate these pictures. Once we have calibrated, we will be shown two different things: reprojection error and pattern centric. So as for the pattern centric, MATLAB will show the angles of the camera that we have moved, and camera centric is where the camera will be in a still stationary place and the image will be shown as the in different angles. So as you can see, we can rotate this and look for ourselves. As for the graph, it shows the reprojection errors. Once all this have been calibrated, we just have to generate MATLAB script. Once we generate MATLAB script, MATLAB will automatically show us the code that we need for the calibration process. Once we run and time the code, these are the results that we obtain. The results will be this. It will show standard error and estimated camera parameter. It will show the focal length of our camera, principal point of our camera, radical distortion of our camera, and this one will be the rotation vector for all 10 pictures and translation vectors for all 10 pictures. Once we run this program, the pops up will be these two graphs where we just seen it in camera calibrator. This is the figures that will pop up once we run this code, and as we can see here, this one can be also rotated and seen in the way we want. And this is the reprojection error for our images that we took. So that's all from me. Thank you.
Hello and Assalamualaikum. My name is Awanku Shafiq. So today I want to show or demonstrate for our assignment 1, that is calibrate camera. So first I will use the apps. Between I am using MATLAB. So first I will choose camera calibrator. Then it will be loading. Then firstly I will add the image from the file. So I will select out. Okay, this will be the setting, so I will okay. So it will be detecting the checkerboard in image 1/10. Okay, I take a photo, 10 pictures. This is from my phone. This is iPhone 13 Pro Max. Okay, it will be detecting all the images. Alright. Yes, this is all the image that I have taken. So this have 10 image. So first I will change it to coefficient and I will calibrate. So the yellow one is a checkerboard origin, and the green one is a detected point, and the red one is reprojecting point. So this is the parameters, the graph. This is the graph that different picture have different parameters. So I will export and generate MATLAB. So this will be the coding. So I will run at the time. So I will put a vision for my file and I will save it. So it will be run. So just waiting for the graph that we get. It takes too long. So yes, this is my what I get from all the photos. So this is the parameters. So this is mean reproduction error per image. This is 10 images. So this is extrinsic parameter visualization. So this will be the graph. So it will have 10 images, right? So next will be the focal length that I get is, this is my focal length that I get. This is principal point pixels of what I get, and this radial distortion. So this is rotation vectors, and this is translation vectors. Right. This is our output that I get. So thanks you. That's all for me. Hello and Assalamualaikum. My name is Awanku Shafiq. So my metric ID will be DE190089. So today I want to present calibration comparison. So we have three models, that is Vivo V23e 5G, iPhone 12 mini and iPhone 13 Pro Max. So different phone have different value. So for the focal length, the value of fx will be 1003.2658, and for fy will be 1003.8497. So iPhone 12 mini will be the value of fx 911.2136. So for fy will be 910.7725. So for iPhone 13 Pro Max, the fx will be 3058.7835. So for fy will be 3054.1299. So for the principal point, the OX will be 484.2813. So OY will be 634.3364. So for iPhone 12 mini will be 0x OX. The value will be 484.3411. For OY will be 602.0798. So for iPhone 13 Pro Max, the value of OX will be 2018.9381. For OY will be 1502.9334. So for the radial distortion coefficient, for the K1 for Vivo will be 0.1502, K2 will be negative 0.4476, the K3 will be 0.3958. So for iPhone 12 mini, the value of K1 is negative 0.0157, K2 will be 0.1301, and K3 will be 0.2503. So for iPhone 13 Pro Max, the value of K1 is 0.3099. For K2 will be negative 2.1746. The K3 will be 5.3163. So for the tangential distortion coefficient, the value is all the same, P1 over P2 over 0. So all the phone have a different value, different focal length, such as principal point, radiation distortion coefficient. So the different phone have a different characteristics, and different camera and a different specs uh, for the camera, for the lens have the different specs. That's why that have a different value. So for me, I think the good the the good camera will be iPhone 13 Pro Max because it has a high megapixel. So that's all for me. Thank you.